with Singapore's 56-story residential towers. I am honored to present our speakers today, Dr. Tan Teng Hoi, Independent Director at TW-Asia Consultants, and his assistant, Wong Feng. Please give him a warm welcome.
All right, thank you for coming to this presentation. I know that it's just after lunch. It can get a little bit sleepy after a while, especially for very boring technical talk. Well, as you can see, the title here is a 56-story residential tower. I think it's probably the tallest concrete modular building in the world currently. So, so before I start, how many have been to Singapore? Good. You see, it's a country jungle. The reason why I need to go to the historical development of the construction industry is because we are small and we cannot afford to have too many foreign laborers because tight work is too intensive. So they have been promoting, the government has been promoting offsite for the last 30-40 years. But previously, they were mostly restricted to two-dimensional elements, just beams, walls, and all that. So for the last 5 to 10 years, they have been trying to push to go for volumetric. So volumetric, to come to this point, it takes a long time because we need confidence, we need experience. So we started with what we call this prefabricated, pre-finished volumetric construction. We started with probably 10 stories, 20 stories, and slowly getting the confidence and experience, especially for the contractors, and the teamwork between the consulting contractors to slowly build up the confidence and build higher and higher. So the point now that they reach 56 stories, it may even go higher. So this is the background to why we come here to show you that we have slowly come a long way to see how we can continue to move on for a concrete modular building. I have the outline of the presentation. I will give the background of the company because I'm the independent director. My full-time job is I'm a professor in university, but I do give technical advice to the company. And I will talk basic information about the PVVC system in Singapore so that you have an understanding of how different it is compared to all the other modular systems. And then I will go into the details of this 56-story. It's a residential building, the structural design, particularly for modular system. As you go higher, it gets more complicated for the structural system. And not only that, the MEP system also get more complicated. Your plumbing system, your electrical system need to be coordinated, and they get bigger and bigger as you go higher and higher. So that kind of coordination is very essential in the fabrication and the design stage. And of course, I'll touch on the construction and the installation, the time frame, the logistical issues, and how fast we could improve the construction time. Of course, I will summarize by telling you definitely there are challenges. I'll highlight one of the key challenges we felt along the way, and of course, I'll start with some concluding remarks. So these are all the PPVC buildings that have been completed, many. Okay, in fact, this is just a handful of them. I'll show you what they are. Now, TW-Asia has been around for many years. Currently, there are offices in Vietnam, in Thailand, and of course in Singapore and Malaysia. So there are about currently 160 full-time staff. And they are still expanding because there is a great interest in having modular design and construction in the region as well. So this is where we try to see whether we are able to learn from you and probably share what we have experienced so far. So these are the offices that we have in the region. And the number of projects we have done. As I said earlier, it started very small. These are the completed ones. We have 5-story, we have 20 story, we have 39 story, 40 stories. These are 16 completed projects. And ongoing, we have another 18 projects ongoing. And of course, the 56-story has already been completed. So we still have many other buildings, all of them in concrete, and 32-story, 37-story, some in Singapore, some in Malaysia, and some in other countries. Okay, the background to this PVVC precast, pre-finished volumetric construction that which our the industry has come to get to. So what is this prefabricated pre-finish? We call it TW-Asia, we don't call it modular there. It's basically the freestanding volumetric modules completely finishing. It will show you the extent of finishing that will be done on site, off-site, and to give you a comparison how fast you can do it. So we have the constructor that assemble and the manufacturer that assemble. There are two parts. Most of the work will be done off-site, which in this case, Singapore's land is very expensive. So most of the fabrication, they are all done in Malaysia, just across the causeway, and they are shipped to Singapore. And then you do the on-site finishing work, and then just on time, deliver to site in the right sequence for the installation. So the coordination is extremely important. The logistical planning is extremely important. So it shows you just a typical layout. Unlike many of those, like hotels, is a lot more straightforward, where you have rooms of very typical design. Whereas in a residential apartment, the developer would like to have variations in the different apartments. And different variations will require different modules. So in that sense, you can see that even just a single apartment, you will have 4 modules. One module comprising of the living and dining balcony, and then you have another module for the bedroom, another module bedroom plus your bathroom and all that, and also another module for the kitchen. So this is only for one apartment. In the residential condominium, you will have different variations of that. So for this particular project, we're talking about 24 different types of modules. And you have to make sure that they fit in the right place and the right time. Advantages of PVVC, like I've said earlier, most important motivation is to have less reliance on foreign construction workers and improve productivity. You can see later that the number of workers required for the comparing to the total on-site and off-site, there's a big advantage in terms of reduction in the site safety and also the productivity. Improvement in quality of end products, because the finishing work, they're all done in the factory. So you get better finishing architectural work, better finishing in the MEP services as well. Now, just to give a comparison, there are a number of steel PVVC projects in Singapore, but somehow it is not popular. Like what Julian has said, it could be a cultural problem, but I think historically, concrete has been used in Singapore. The main reason is because of price. It's cheaper to do in concrete. We do have steel building in that sense that it's cheaper because we could complete the building in a shorter time, mainly for commercial building. But for residential building, there's no preference for concrete, steel, because it tends to give a different indication that it looks like a factory, because it's steel, and then you need your fire insulation and all that. So, and it's not, so the insulation has a little bit of problem. You need to do a special insulation, because for apartment, you want to have better sound insulation. So let's look at the advantages and disadvantages. Concrete PVVC, lower cost, and I've said concrete is always cheaper. Of course, nowadays we're talking about sustainability, the carbon emission and all that. Of course, materials are readily available. People are familiar with concrete construction. The workers are familiar, the contractors are familiar. Acoustic property is certainly better because it's more robust, denser. You get a better acoustic properties compared to a steel construction. Durability, much better. You don't have the corrosion problem with concrete. And of course, lower maintenance. Disadvantages, very heavy modules. So because of the concrete construction, because of PVVC, in fact, one comment I had from some of the visitors they were saying that they have never seen such big tower crane in their life. Huge tower crane in order to lift all these modules up. Very, very heavy investment on the tower cranes. And of course, the crane consideration, because not just the size of the tower crane, your boom length and all that to make sure the tower, the site is a big consideration, whether the number of tower crane needed. For steel PVC, there are a few projects in Singapore. Certainly like the modules, better construction tolerance. And of course, the disadvantage compared to that is higher cost, fire rating, particularly in Singapore. We still need to have fire rating unless you go for performance-based. And steel construction, you have this need to have protection against corrosion or rusting, acoustic rating, especially if you use drywall for your system, then you will have to make sure that you meet the acoustic requirement, and also long-term maintenance issue. But most of it due to the corrosion problem from the steel. Advantages, now this is where we try to differentiate the modular system that we have in most of the other places than what we have here. Now what we do here for this modular system is that we try to emulate a modular system eventually is served like a monolithic system. In other words, you have to stitch all the modular modules together and stitch them to become monolithic. So you have a lot of shear wall system that are created because of the stitching between all the modules. So eventually the building will have many shear walls. The shear walls are the connecting part that we stitch together between the modules. And it's a patented system that this TW-Asia has that allows you to have a monolithic performance but it's a modular construction method. Inner walls, particularly for residential apartment. Residential apartment, people do not like to have kings on the walls. They want to have a flat wall. So the shear wall system allows you to have a flat wall, so that as if there is no column within the any obstructions or irregularity along the walls. So there are no column kings, and you have higher headroom because there are no beams, except a local one beam at at the doorway. Otherwise, there are no beams in the system. No bulkhead visible as there are no beam protrusion. So of course, it's a six-sided PVC system. It's a box, six-sided box. So during production, during transportation, during installation, it's a lot more robust. It's a very robust system, especially you need to lift it and then to a very high level. Opening provision can be designed and catered for future expansion. Structural robustness, even for high-rise building, this is where we ensure that you're able to have the concrete walls stitched together to form a monolithic performance. So you have a typical PVC concrete system here. Weekly six-sided, you have structural elements and you have non-structural elements. And of course, the key benefit is stable and it has good acoustic property. The next slide will show you a better indication of where the structural and non-structural part. The structural part will be this part where you'll be stitched with the next panel. And of course, you also need to have some parts to be structural. The brown parts are the non-structural wall. Basically, it can be hollow block walls or it can be any plain concrete walls to provide the sound insulation and the partition purpose. The thickness of the walls, or we call them long columns, is 140 millimeters to 90 millimeters. 90 millimeters means that it's only one part of the modular. Eventually, you will have two pieces together and then routed and connected structurally to form a final thickness. The slab is 130 millimeters thick, and of course, there's only one beam, which is at the doorway, and of course, the internal wall, which are non-structural, they are only 100 millimeters thick. Basically, is to reduce the weight. We try to keep the thickness as thin as possible. And of course, it will be fully finished before bringing to site for installation. You have all your flooring, the parquet wooden floor tiles, or even in the homogeneous floor tile for your toilet or the wet areas. You have your wardrobe, you have your wall panels, wall finishing, all will be completed before you leave for installation. So this is another isometric view of the inbuilt bathroom with all your basins and all that. So this, in a way, shows you briefly how the walls will be connected to get stitched together from one module to another. The architectural services that shown earlier. This is now the plan view. You can see that you have the structural wall. These are the structural wall for one apartment. You have the one of the wall here which will be connected to another module. The structural wall in red. You have two thicknesses: the light brown, or the brown will be 90mm structural wall, and 150mm structural wall. Non-structural, those are in yellow or light green or the thicker green. Those are the non-structural walls. Of course, you have the windows and all that will be in place. So this is just one typical apartment. There are different variations of the apartment layout. And finishing for the architectural will be for the kitchen. You have the floor height will be 2.4 meters headroom, and then the shower. All of them shower will have 2.3 meters of the headroom and the corridors and all that. So this is just the isometric view to show there are already 3 modules here connected together to form one apartment. Another section of the apartment, a typical apartment, to show you how the layout of the kitchen, the rooms, and the toilets. The buildable code, there are requirements in terms of the installation of your architectural finishing and also the MEP services. So this indicates where you need to comply with the requirements. Later I'll show you what are the requirements. The requirements will be that for floor finishing, that you will have to finish 80% of them offsite. The remaining, there will be some part that you need to stitch them together. Even for the floor, you touch up some of the floor finishing. Wall finishing, 100% completed offsite. The painting, only base coat. You do the final finishing coat when the construction is completed. Doors, you will leave it for on-site installation, only for the door leaves. Wardrobe and cabinet completed except for the doors. The M&E services mostly completed. You just need to do the connection on site. All the water supply, the plumbing, the electrical wiring, they will be all done in the factory off-site, and then connection will be done on-site. Okay, and the light fittings or chandeliers, whatever you have, will be done after you completed your installation on site. So this basically show you that the green part will show you all the stuff that you have to do off-site. So you will have to have localized connection, some wet tricks here, and you have to finish up your tiling between the units and also at the joint area. These are the minimum work that you have to do on site. So now we go to the project itself. Previously, they were just the typical layout for PPVC project. For this particular project, there are basically 2 blocks, 2 tower blocks, each of them 56-story high, a total of 988 apartment units. And there are 3,000 over modules to be fabricated off-site and then brought to the site to be assembled together. So it's currently, I think, it's still the tallest concrete PVC tower, 56-story. To show the structure, okay, this is the time-lapse photography of it's completed to show you what happened. You have the core walls, slip form, going up as we stack up the modules. I'll show you the next slide, yes. The details will come in the next slide. Tower 1 started earlier. That's the part that the contractor needs to be familiar with the logistics and all that. So it took slightly longer time. Tower 1 took about 18 months for the 56 story. So by the time they went to the Tower 2, they were a lot more familiar with the logistics of it. So they could finish that in 15 months for 56 story. So it's a big reduction in the construction time. So in terms of the government authority has been promoting the use of off-site construction, particularly PVDC. So they have index for us to ensure that we are able to comply with the requirement. So the requirement for constructability in this case is 60. There are some indexes that you need to work it out. So for this particular project, they could achieve far what the requirement was. It's 67. The buildable score is the requirement, minimum requirement is 88. They could go all the way to 95. So in fact, it's much better than what the government expected the project to achieve. The manpower productivity achievement, the change was from 0.357 meters squared per man day, they work by per man day, to 0.613, something like 60 to 70% improvement in the productivity. I mean, the manpower reduction is a big saving. Productivity improvement using PVC, in this case, if you work out, about 72%. So it's a big reduction, which the main motivation is reduction in the manpower for the project. Now, the structural concept for the building is that the foundation is a 3.5 meter thick rough foundation resting on wall piles. The lower floors, they are not PVC, they are traditional on-site construction, flat slab with drop panels. The third story is a sky terrace where you have the transfer plate for the PVC tower to sit on. And then from the fourth story onwards to 56 story, they are all PVC except there are two interruptions. These two interruptions will be basically they are the sky garden. If you look at the previous slide, I don't have it yet. Probably the next slide will show it. You will have the sky garden on the 19th story, and the 36th story again. This is on the on-site construction only for the two floors. The rest are all PVC. So the on-site traditional construction for a sky garden is basically a beam slab system. As you can see here, from the plan, you can see that there are different apartment arrangement. Because it will be too boring for the developer to issue only one type of apartment. So they have different variation, different size, so that people can buy according to their affordability. And because of the variations of the apartment type, we end up with 24 different type modules off-site. So you can see all the different colors to show you all the modules that need to put in. As you can see, they are the sky garden. They have to be done on-site. The rest are all PVDCs. As I said earlier, the system is such that we use the modular system to enable the connection to form a monolithic system. And you can see that when the two modules are put together, the stitching will be done to ensure that it becomes a monolithic shear wall. So you have a lot of monolithic shear wall system that allow the building to have a monolithic performance similar to a building that is done on-site in terms of the structural performance. So the thickness of the wall is shown here. You have ranging from the core walls are about 350 slip forming, 300 for a slip form, and then the end gable walls will be 350, and some of the other staircase walls, they are 400 millimeters thick. There's requirement for the structural, lateral structural resistance and stability. This shows you the modules, different shapes and different size of the modules that need to be put together, PVC module, to form the entire tower block. As you can see that not the entire floor is made of PVC. Only just about just below 70% is actually PVC. 30% or 31% of the floor is actually monolithic concrete on-site construction to give you connectivity and also better lateral connectivity and robustness. So it's not totally PVC. It will reduce the amount of on-site, but you still have to retain about 31% for the on-site construction, which is minimum in that sense. Tower lateral load performance, we have done the analysis, and it has actually performed extremely well. It is, in this case, for the stiffer direction, at the top of the 56-story unit have up to the maximum wind load. In Singapore, we don't have seismic, so it's only designed for the wind load. So we only have 103 millimeters deflection. And of course, the requirement is that it should not exceed 390. So we actually done quite well for a stiffer direction. Whereas for the less steep direction, the requirement is 390 millimeters deflection, which is based on 1:500. This building can achieve less than 300. So in that sense, it usually works almost as good as monolithic building. This is stability. We have done the dynamic analysis. The mood shape and all that is the lateral. First mode is lateral, which is 7.2 second time period. Second mood shape, the first mood shape. Second also is lateral translational. And the deflection lateral displacement that I mentioned earlier is better than 1/500. Wind tunnel test was also conducted for these two towers to determine the wind pressure for the design of the building as well as for the design of the claddings. So this just some photographs of the wind tunnel test, and then the information from the wind tunnel test was then compared with what we have obtained from the ETAP assumption based on the building code, and in this case it shows that the provision from the ETAP model is much higher than what we obtained from the wind tunnel test. We also did the serviceability peak deflection in terms of the comfort based on deflection and also based on the acceleration. It should show, I think it's in the building acceleration, human comfort, and also the deflection, tip deflection. Yellow part with flying colors. As I said earlier, we had to do the wind tunnel test and also do the prediction of the wind profile to determine the pressure on the building for the building design as well as for the cladding design of the windows and all the cladding walls. So the next few slides will basically show you the module layout. This is just to show one of the apartments here to show you how they are stacked together and how they are stitched together at the connecting walls. The PVC system will have the reinforced concrete top slab, the ceiling slab, the concrete shear wall, 100 millimeters thick, and then a small beam here for the across the doorway, and also the cantilever slab here for the balcony. So the slab is basically all simply supported across the walls of the modules. Now the requirement is, because it's non-seismic, we still need to check for the robustness of the building. So the code requires the notional horizontal load to check to make sure that there are sufficient robustness and stability, tie requirements provided in the building. So there will be horizontal ties in the peripheral ties, internal ties. These are according to the Euro code. That you have to put in a minimum tie to ensure that the building is robust. The vertical ties and the continuity of ties. All these are being provided in the connecting part, the on-site the connection between the modules. In order to ensure that the stitching between the modules to form the monolithic walls, the actual tests were done in the laboratories. We sent it to the university, and they did the column test to make sure there is no separation, and also we did the actual shear bond test to make sure that there is sufficient shear transfer. And they all passed as good as if they are monolithic construction. So this simply show you for a 3-bedroom apartment how these modules are being put together to form one apartment. Now we go to the MEP system. For the electrical system, of course, you have all the electrical wiring already done in the units. Between the units, they're all done using the junction boxes. You only connect the wiring to the junction boxes. Air conditioning similarly will be already, all the conduits are already provided. So as you can see that the architectural work, the MEP, and the structural work need to work closely together from day one to ensure that everything works together and form a unit that works. In fact, they have the same team for the project when you are starting low, and they work together as they go on in all the other higher projects. So you can see that they're familiar with the how things work, what things don't work, how they can improve it for the next project and all that. So they have actually learned a lot along the way in terms of how to get things done the best to ensure that it works completely. So teamwork is extremely important for modular construction. So between the floor, the vertical the stack for the plumbing, there's very flexible joint there to ensure that the waste and all that do come down between the modular units. So this is a 3D view of the M&E system with all your piping and your electrical system. And basically for the wiring, I said earlier, the connection is through the junction boxes. The pipes and all that, they are flexible sleeves at specific location for them to connect the, for example, water pipe only one connection point, so that the distribution is within the unit itself. So these are the M&E services to show you how they are being run. And the coupling for the pipe and the electrical wiring, most of them are within the unit. Then you connect them into a single junction box. And of course, we need to meet the code of practice. Within the country, we have our own code of practice to ensure that all the bathroom, sanitary, water services, they need to meet the statutory requirement. Okay, and there are standard requirements that we need to comply with. So this shows you how we can connect them together in each of those modules. See that the main one is because as you go higher and higher, the pipe gets bigger and bigger. So you need to ensure that especially for the sanitary pipe, you need to make sure that it cater for the right size, and then you need to have the flexible joint to put them together. Now, in terms of construction, offsite, the limitation is basically the transportation, because you cannot have too big, you have problem on the public roads. So the size is in a way limited. You can see that the width is basically within 3.1 meters, so that it doesn't go beyond a normal road width. So 3.1 meters, the length you can have up to 8.35 meters. Smallest unit is 5.75 meter in length, but the width is controlled by 3.1 or 3 meters. Because of the concrete construction, it's a massive weight. It can weigh up to 29 tons for the heaviest unit. So you need really massive tower cranes in order to lift, especially all the way to 56 story. So the height of the module is 3.15 meters. Basically, it's about the floor to floor height. And I said earlier, the casting of the units, they're all done in Malaysia, just across the causeway. And then they will bring in either by the road or the barges to the fit-out yard where you put in your architectural finishing or the M&E services, MEP services. And then once they're finished your fit-out yard, you will bring them according to the day schedule to the construction site for installation. So it's a production plant. It's a very long casting yard that is able to do the continuous construction. I like to say steel is a lot easier. For concrete, you need time for the curing and hardening and all that. So it's slower, but the production, you can see that the size of the plant, the precast plant is 23 acres. Total production capacity is 55,000 cubic meter. I believe that's the concrete volume. There are 2 casting yards, and then of course there's another one. C9 is 15,000 cubic meter per month. Huge site for the offsite production. So this is a trailer. As you can see that it's limited by the width of the trailer. The trailer is 3.2 meters. Length of course is much longer. You can put in the longest we have is 8.5 meters. So this is the plan of the site. There are 2 tower cranes. The tower crane must have the capacity to lift even at this distance to the furthest point for the heaviest unit. So the planning of the location of tower crane is very important to ensure that you have successful lifting of all the units on time, and also the logistic of which unit go first. So the schedule is extremely important. So this is massive crane that allows you the turning radius of, at this, the furthest point is you are able to lift 29 tons at 40 meter radius. Massive tower crane. Some of the photographs of the off-site fabrication. And then these are the fitting out yards. And this is the installation of the modules on site. And then you have the monolithic grouting of the connecting walls to make sure that they are monolithic. So this is where they have to do the grouting for the 2 walls. The self-compacting concrete for the grouting of the walls. Key challenges. The heavier modules, I've said earlier, 39 tons, you will require bigger and bigger crane, especially nowadays they want to reduce the number of modules. The module becomes too heavy, so you need to think of how to overcome this problem. Fabrication yard, you need to have a big fabrication yard, especially for concrete construction. Key challenges. Interface connection between modules need to be level and aligned. As you can see that the tolerance for concrete construction is not as good as steel. So the construction tolerance still have to be controlled very well at the fabrication yard and installation. You can imagine that if you make mistake, it will accumulate as you go up to 56 story. So the control is extremely important. Pre-match trial for the module must be done in the factory. Robustness of the building to be achieved with structural connection. That's the one that is a patented system to allow to form walls into a monolithic wall. Concluding remarks. Collaboration between the client, consultant, and contractor has to be at the onset. In fact, the government has been pushing and encouraging the industry to move towards off-site construction. In fact, it's now a requirement. If there's a land sale from the government, the land sale stipulates that you must use off-site construction. Otherwise, you won't be successful in the land sale. So all the developers, when they come in, they already have the team behind them. The contractors, the architects, the MEP consultant, they already work out what they need to do before they go for the land bidding. It's a requirement. So in that sense, the collaboration is already done even before going for the buying the land. So the team is already formed. And the team, usually they have worked together before, so they are able to know what are the challenges they face before, and they improve on it. Every project, they get better and better. So deliberation of the technical details, evaluation of the production proposal, where you want to get your casting done. You can't get your land and then start to look for land for your casting done. It's already too late. So you have to get everything planned beforehand. Primary depletion, consensus is essential for progress. As you can see that every module you need so many things to be put in. So the collaboration and the teamwork between the consultants, architectural, and MEP and structural is extremely important. Okay, collaboration is the key word. Thank you very much.